Okay, guys, we are going to discuss parent functions, transforming them with H and K. So we are going to look at just these boxes right here in terms of H and this one in terms of K. So I would like to point out that when we talk about H here, we are going to go right and left. And we talk about K, we're going to go up and down. So we're going to do this in several different times, and it's going to be a long notes video, but I need you to stick with me. So if I look at this parent function of an absolute value, I want to point out that it says x minus h up here in the equation, but if you notice here it says x plus 4. What I want you to do every single time that you do this is I want you to do x plus 4 equal to 0, and I want you to subtract 4 and solve it. So x is negative 4. So the x in my vertex is negative 4. The k, because the vertex is hk, is out here, and it doesn't change. It's always a positive 5. So what I'm going to do to start is I am going to graph the parent function, and that's on your notes paper. Okay, so the parent function of an absolute value looks like this. Okay, now I'm going to graph the new vertex of negative 4, 5, and I want to talk about how it transformed from the green vertex to the blue vertex. So what it did, and if you see, look at my H up in the box. It says if H is less than 1, it goes left, and it did. It went left 4. And then if you look at my K, if K is greater than 0, which it is, it's positive 5, it goes up 5, or it goes up, and in this case it goes up 5. So that is how I transform it based on my vertex. Now to get my two other points, I look at my negative 4x value, and I'm going to go one to the right and one to the left. So I'm going to plug in negative 3 here. I'm going to do negative 3 plus 4. Oh, sorry, not absolute value, is 1. The absolute value of 1 is 1. 1 plus 5 is 6. Now, an absolute value function is symmetrical, so this is also 6. So when I go to graph that, I know it's here and here. Sorry, that is not fabulous, but you get the idea. There you go. So I have that. Now I'm going to go to my x-intercept. Remember, the x-intercept is where it's going to cross the x-axis. And this blue function is never going to cross this x-axis. So my x-intercept is none. Now when I go to get the y-intercept is where it crosses the y-axis. And the blue is going to cross the y. To figure that out, I'm going to plug in 0 for x. So I'm going to do 0 plus 4. The absolute value is 4. 4 plus 5 is 9. So my y-intercept is 9, and I can also graph 0, 9 and finish out my absolute value. Okay, then if I'm going to go to my domain for an absolute value is always negative infinity to positive infinity. But my range is my y value. My y value appears at 5. So it's bracket 5, infinity. And you have just transformed your first absolute value function. All right, let's do the next one. Okay, again, I'm going to graph my parent function first. So this is my parent function, just because I think it helps visually you guys see where it goes. Now, I told you I want you to set this equal to 0. So add 2. So x equals 2. So my vertex is 2. But there is no k. There's no value on the outside there. So it is just 0. So my transformed vertex is 2, 0. Well, I didn't go up, but I did go right 2. And then that's all you have to say. Now my x-intercept, my vertex is actually on the x-axis, so I'm going to say my x-intercept is 2. And then I'm going to go 1 to the right and 1 to the left and plug it in. 1 minus 2 is -1. The absolute value of -1 is 1. And I know it's symmetrical. So it's 3, 1, and 1, 1. And then to get my y-intercept, I'm going to plug 0 in. So 0 minus 2 equals -2. The absolute value of -2 is 2. So my y-intercept is 2, and it's right there. And you can do that other point symmetrically. And I can see right now that it is going to have an x-intercept and a y-intercept. So I'm going to do the y first. I'm going to plug 0 in here. So 0 minus 3 squared minus 6. Negative 3 squared is 9. 9 minus 6 is 3. So my y-intercept is 3 at 0, 3, all the way up there. Okay. If you wanted, you can find the other ones, but some other points, but that's okay. But let's look at the x-intercept, okay? That one doesn't come quite as easily as it has before. So to find an x-intercept, you need to plug 0 in for y, or f of x. So I'm going to have 0 equals x minus 3 squared minus 6. So I'm going to add 6, so 6 equals x minus 3 squared. The opposite of squaring something is square rooting something. So I'm going to have the square root of 6 equals x minus 3. Add 3. And you can say that the x-intercept is 3 plus radical 6. And that is fine. I'm not going to give you one like that for your test. Okay? Not going to do that. The domain is negative infinity to positive infinity. The range, okay, you guys, it's down here. Look at your y value. So it is bracket negative 6, infinity. Okay. Now we are going to write an equation here. Write an equation. So I'm using a quadratic, so I can do y equals or f of x, it doesn't matter. I'm going down and left. Remember, left is my h value and down is my k value. So I flipped the order on how I asked this, but you can do it. So we're going to have x, since it's left, we're going to change it to plus 4 squared and then down 12. That is writing the equation given the transformation. Okay. All right. So now we are going to go, maybe, if I can move, I don't know why it's not letting me, there we go, to, where is my cubic function? Oh, there they are. Okay, cubic functions. So, same thing. I am going to do x minus 2 equals 0, add 2, nope, okay, add 2, so my starting point is going to be 2, 1, okay, which means I'm going to go right 2 and up 1. So right 2 and up 1. Remember, your cubic function is curved. It's curved. So I'm going to plug in 1 and 3. Now this is not symmetrical, so you need to pay attention to that. So I'm going to do 1 minus 2 is negative 1. Negative 1 cubed is negative 1. Negative 1 plus 1 is 0. Boom! I found my x-intercept. So 1, 0. Now I can assume that it's going to be the up 1 over 1 here. So I'm going to do 3 minus 2 is 1. 1 cubed is 1. And so this 1 plus 1 is 2. So 3, 2. So I know that's what's going to happen. Now I need to figure out your y-intercept. So I'm going to plug 0 in for x. 0 minus 2 is negative 2. Negative 2 cubed is negative 8. Negative 8 plus 1 is negative 7. So I know this is 0, negative 7 down here. All right. And you could plug in 4, and you will get 9 up here. And there's your cubic function. I told you guys before, this is the only one, negative infinity, positive infinity, always. You don't even got to think about it, no matter what the transformation is. That is always what's happens. So that's the awesome thing about that. Okay, so if I go to number 9, I know it's a cubic function. I'm actually just going to put that in here. I'm just going to put negative infinity to positive because I know exactly that's what it is every single time. Okay, now if you notice in the x, it says x to the third. It doesn't have a number in there with x, so that my starting point is 0, and then negative 3. So the only transformation is down 3. I'm going to go down 3 there. So I'm still going to do 1 and negative 1. So 1 cubed is 1, minus 3 is negative 2, and then negative 1 cubed is negative 1, minus 3 is negative 4. So 1, negative, nope, not there. 1, negative 2, and negative 1, negative 4. Okay. I can see already that what the y-intercept is. The y-intercept is negative 3. That's right there at the vertex, so I'm good there. I have to plug in 0 for f of x or y, so I'm going to do 0 equals x to the third minus 3. I'm going to add 3. X to the third equals 3. I have to cube root it, and you can just leave that as your x-intercept. So the cube root of 3. So we know this function is going to go just like that. You don't really have to do a couple extra points. I'm good with just that. Okay. All right, let's go to number 10. I believe that was over this way. Let me see. Yeah, there it is. All right. So now we have a square root function. Remember, this is the half an arc. So I'm going to do x minus 3 equals 0, add 3, add 3. So x equals 3, so my starting point is going to be 3, 4. So 3, 4 right there. Okay. Now, it can't go past that 3 because if you do it, you're going to have a negative in the under there, and you can't square root a negative. So I am going to say, though, I'm going to go right 3 and up 4. That's my transformation. Now, I have to pick numbers, and usually the next one is good. That is going to end up being a perfect square. So I'm going to do 4 minus 3 is 1, square root of 1 is 1, 1 plus 4 is 5. Now, so 4, 5. Sorry, there was a little bit of pause there. That was my bad. Hopefully that continued. If I picked 5, 5 minus 3 is 2, and the square root of 2 is not fun. So I'm going to pick 7, because if I do 7 minus 3, I get 4. The square root of 4 is 2. 2 plus 4 is 6. So 7, 6. And that's good enough for me. Okay? If you look, that's not going to cross the x-axis, and it's not going to cross the y-axis. So my x and y intercept are none. Now, going to look at this for my x-axis, basically it's your domain. Or for your domain, you look at your x value, and that's 3. So it's bracket 3, positive infinity. And for your range, that's at 4, or the y value in your vertex, or your starting point, and there you go. Okay, let's do another one. So I'm going to have x plus 1 equals 0, subtract 1, x equals negative 1, so my starting point is negative 1, negative 3. That means I'm going to go left 1, it's not erasing. It's taking too long to think about it, apparently. Left 1 and down 3. Okay, so I'm going to do that. I'm going to go left 1 and down 3. My vertex is right here. I am going to plug in 0. 0 plus 1 is 1, the square root of 1 is 1, and negative 2. So that is also my y-intercept, 0, negative 2. Okay. I don't know what just happened, why that did that. Oh, I don't know why. Okay, sorry. So then I can plug in 3 because 3 plus 1 gives me 4. The square root of 4 is 2. 2 minus 1 is negative 1. So 3 and negative 1 is going to be right there. And 0, 2 is right there. It's approximately there. Now, to get the x-intercept, I know I have to have 0 equals the square root of x plus 1 minus 3. So I'm going to add 3, add 3. So 3 equals the square root of x plus 1. I'm going to square both sides. So x plus 1 equals 9 minus 1. So my x-intercept is 8. So 0, 8, which it does look like it would be right there on that graph. Okay. My domain, again, starts at my x value. My x and my vertex is negative 1, infinity. And my range is my y, which is negative 3, infinity. Okay. All right, let's write an equation. And then we really just have them matching, but I'm going to have you guys look at that, or we'll look at it in class. But so if we look here, we're going to go down and right. Remember, right is your h, and this is your k. So y equals the square root. We're going to go right. So x minus 17, and down 4 is minus 4. Okay? That concludes HK transformation notes.